In this video, I'm working with students on solving a system of equations by substitution, and we're using 2 column notes to help them summarize those procedures, so to retain that information and show reasoning of why each step is being done. And so on the first one example, you can see it's actually going to be a line that intersects because I went ahead and did step 1, which was to solve for y, because it was the variable with a 1 in front of it. And then on step 2, we substituted 3x plus 4 in for y. We replaced 3x plus 4 in for y into the first equation, and that's step 2. And then we actually had to solve it, so I distributed the 2. 2 times 3x was 6x, and 2 times 4 was 8. And once I solve for x, I get 0, so I go back up on step 4, and I actually solve for y. In that first equation we solved for, so if x is 0, 3 times 0 plus 4, then y is going to be equal to 4. And now the final step is to actually check your solution. So remember, it's 0, 4. So if I plug that back into both equations, I have negative 4 times 0 plus 2 times 4, and that does equal 8, so that checks. And then check the second equation, negative 3 times 0 plus 4 does also equal 4. So both of them check, and that is the intersection point of those two lines. The second example, y is already solved for in the first step, so step 1 is done for me. And so now I substitute or replace the y in the second equation. So on step 2, I'm going to make the substitution. So negative 6x plus 6x minus 2 equals 4. And then I'm going to solve it. So that's going to be the negative 6x and 6x go to 0. And I'm left with negative 2 equals 4, which is never going to be true. Negative 2 is never equal to negative 4. And that's what it looked like when it was no solution, also when we were solving one equation. But it means something different. It means that the two lines will share no common point since there's two equations, and therefore it's going to be parallel lines, is what the interpretation of that solution is for system of equations. And then the last example I can solve for x or y in the top equation. So I'm going to solve for y. So if y is equal to negative x plus 6, that's going to be the first step that you actually solve for one of the variables. Doesn't matter which one, just you solve for one of them though. And then I'm going to replace y in the second equation with negative x plus 6. So on step 2, I'm going to make that substitution. And we talked about that when you substitute, you actually replace, just like an athlete replaces another sports member on a team if they substitute in. And so you have 2x plus 2 times negative x plus 6 equals 12. And now you're going to solve it. So now you have 2x minus 2x plus 12 equals 12. And the 2x's go to 0, and you're left with 12 equals 12, which is always true. And so that's going to be infinitely many solutions. Many solutions. And what that means is that the two lines, or the two equations that we are looking at in example 3, are the exact same line. And so one way you can tell also, if you look at those, we talked about what's the pattern you see in the last example, and is that it is a multiple of the other line. There's actually a 2 just multiplied through the entire equation. And when you multiply a number through an entire equation, it doesn't change the line, it just changes the numbers.